this problem, we have to first find out what the work is, and the work is the force on this dimension, and force is mass times gravity times the displacement, and the displacement here is 4 based on the values that we get. So using that, we can plug in numbers, and let's just go ahead and suppose that our mass is 3 kilograms. We'll use that for this example. So multiplying, we have 4 times the mass times 10 meters per second squared. And if we simplify this, that's 120 joules. Now, next up, we have to find the velocity at v or y equals 6. So that would be work equals the change in the kinetic energy. So simplifying that, we know that the work put in is mg times 4, that displacement, equals, breaking this down, it's half. This is the kinetic energy and the potential energy. And that's going to be the 10. So now what we can go ahead and do is plug this in. So this is going to remain the same, and there is no potential energy. So we just have mg4 equals half of the kinetic energy present. So we can simplify this by removing an m from each side and multiplying each side by 2. So we would have 2g4 equals 1/2 v squared, and we know that y2 is 6 based on this. So further simplifying this problem, we are left with v squared equals 8g over 6. Now we have to find that square root. The square root of that is v equals 3.6 meters per second, or 4 meters per second. And that is our answer for B. Now, moving on to C. C, we have to generalize the equation. So how we would generalize the equation is using the work equals 2 times the mass and the grams, with the absolute value of the displacement of y equals the kinetic energy squared. So basically, to simplify this, to simplify this, what we can do is multiply each side by 2 and remove an m from each side. So we're left with vf squared equals 2g with absolute value of y, which means that v equals the square root of 2g, the absolute value of the displacement of y, and that's how we'd be able to find the velocity of anything using any different y. Now for D, we would have to work out using the work equals the mass times the gravity of y1 minus y2, which would be equal to the potential energy y1 minus the potential energy y2. So basically, the potential energy of y1 is equal to mass times grams times y1. Potential energy of y2 is equal to mass times the gravity of y2. And all this, what a rule that applies to this is that y1 is greater than y2. And that has to be valid. Now, for E, This is a really long one. E is going to be the work equals the change in the kinetic energy, which equals the change in the potential energy, as we mentioned in the previous. So simplifying this and breaking it out even more, it's going to be K final minus K initial equals U final minus U initial. And we want to combine like terms, so that means that K final plus U final equals U initial plus K initial. And further simplifying that, that's going to give us the kinetic energy plus the potential energy equals kinetic energy of V1 plus that potential energy. And that is the solution to this problem. And basically this is that conservation of energy principle.